Okay, I want you to try a thought experiment with me. It's a big one. So, clear your mind for a second.
All right, I'm ready.
Imagine that everything around you, this desk, the air you're breathing, the gravity holding you down, even the thoughts, firing across your neurons right now. Imagine if all of that wasn't stuff in the traditional sense.
Yeah.
What if it was just the result of simple, abstract rules running over and over again, trillions of times a second, forever?
It sounds like the opening crawl of a sci-fi movie, doesn't it? But you're actually touching on a fundamental premise that might just, well, rewrite our entire understanding of physics.
And existence, really.
And existence.
We are back for another deep dive, and today we're tackling something massive. We're looking at the work of Stephen Wolfram, physicist, computer scientist, the creator of Mathematica. We've got a stack of his writings here, covering everything from the, quote, machine code of the universe to the history of the game of life, and even what it would mean to have an alien mind.
It is a fascinating collection. Wolfram is one of those, rare thinkers who doesn't just want to solve a specific problem in physics. He wants to rebuild the whole foundation from the ground up.
He's asking what's underneath it all.
Exactly. What's underneath the physics we know. And the mission for this deep dive is really to unpack one central mind-bending concept, the Ruliad.
The Ruliad. It sounds ancient, like the Iliad or something.
It does.
But the concept is incredibly futuristic.
Ah.
So let's set the stage. We're used to science being about finding the one true formula for the universe, right? Like physicists are hunting for that one equation that fits on a t-shirt.
The master key, yeah. String theory, quantum loop gravity, they all want that one key.
But Wolfram seems to be suggesting that's the wrong approach entirely.
He is. And this is where the paradigm shift really happens. It's a bit of a shock to the system. Instead of hunting for one specific rule that describes our universe, Wolfram asks us to imagine a structure that contains all possible computational rules.
Hold on. All possible rules. That just sounds like total chaos.
It is, in a way. I mean, imagine every possible computer program, every possible algorithm, every conceivable rule for connecting data, all running simultaneously forever.
Wow.
This infinite abstract object, this entangled limit of everything that is computationally possible, that is what he calls the Ruliad.
Okay, I need to visualize this. Because entangled limit of everything is a bit hard to picture. Is the Ruliad a place? Is it a library? A simulation? What is it?
Think of it less like a physical place and more like a map of all possibilities. To really grasp it, we have to look at how Wolfram views space itself.
Right.
In his physics project, he describes the universe not as a continuous empty box we put stuff into, but as something built from discrete atoms of space.
Atoms of space.
Yeah.
You don't mean atoms like hydrogen or helium.
No, those are way, way too big. These are abstract points, the absolute bottom layer of reality, the machine code, as he puts it.
So space isn't just an empty stage.
No, space is just the network of relations between these points. If point A is connected to point B, they're close. If they're not connected, they're far.
So the universe is basically a giant graph, like a social network of points.
Exactly. A hypergraph, to be precise. And the Ruliad is what happens when you apply every possible rule to update that graph. It traces out every possible history and every possible future at the same time. It's a multi-way system.
So time isn't a single line.
It's a branching, merging network of threads where everything that can happen does happen.
Okay, stop there, because this is where I get stuck. If the Ruliad contains everything, all the chaos, all the nonsense, every possible rule running at once, why aren't we seeing total chaos? I look around and I see a coffee cup that stays a coffee cup.
Right. Gravity works.
Gravity acts predictably. I don't see the universe glitching out. Why do we have logic if the foundation is infinite chaos?
That is the crucial question. It is the aha moment of this entire deep dive. If you take nothing else away, take this. The answer isn't in the Ruliad.
It's not.
The answer is in us.
In us.
Yes. Wolfram explains that the order we see exists solely because we are computationally bounded observers.
Computationally bounded. That sounds like a polite way of saying we're slow and simple.
In a cosmic sense, we are. Think about it this way. Imagine a room full of gas molecules, trillions of them.
Okay.
They are bouncing around chaotically, hitting each other in complex, unpredictable ways. To predict the exact path of every single molecule it's just impossible for us.
Right. It's too much data. It would just look like noise.
Exactly. But because we are large, slow observers compared to those molecules, we don't see the individual chaos. We smooth it out. We perceive the average, we call it temperature or pressure.
So those are simple, stable rules that emerge because we're just ignoring the messy details.
We're ignoring the details. We're seeing the summary, the Reader's Digest version of the universe.
That's a good way to put it.
And Wolfram argues that the laws of physics, general relativity, quantum mechanics, they aren't these arbitrary rules written in the sky. They are the inevitable result of how a bounded observer, like a human, samples this infinite chaotic Ruliad.
So we carve out a slice of reality that our brains can actually handle.
That's it. That is the core idea.
That is humbling. So gravity isn't just there. Gravity is what happens when a mind like ours tries to make sense of this infinite computation.
Exactly. And if we were different kinds of observers, say the size of an atom or with a brain the size of a galaxy, we might perceive completely different laws of physics. Our reality is defined by our limitations.
I want to drill down into why we can't see the details. There's a term in the notes Wolfram uses constantly: computational irreducibility. It sounds academic, but he seems to think it's the key to everything. What does it actually mean?
It is the core mechanism. We are used to shortcuts in science, you know? Think about high school physics. You have a formula. You plug in time equals 10 seconds, and boom, you get the answer for where the ball
You
is.
skip the middle part.
You skip the middle. You don't have to watch the ball fly to know where it lands.
Right. That's the power of math. Prediction.
But Wolfram points out that for most complex systems, and the universe itself is the ultimate complex system, there is no formula. There is no shortcut.
The system is computationally irreducible.
Yes. Which means you cannot predict what will happen 5 steps ahead without actually running the system for 5 steps.
So you can't just jump to the end of the book.
You have to read every page. The computation must be run. The passage of time isn't just some delay. The passage of time is the computation. You have to live the steps to get to the result.
Which explains why we can't predict the future, no matter how good our computers get.
And why we perceive a coherent flow of time. We're embedded in this irreducible process. We can't step outside of it because we are part of it.
Okay, talking about atoms of space and irreducibility is fascinating, but it's very abstract. I want to make this tangible. The sources spend a lot of time on something called the game of life. Now, I know this is a screensaver from the 90s. Why is a physicist obsessed with it?
It does look like a screensaver. It's a cellular automaton invented by John Conway, and it's been studied for, nearly 60 years now. And it's the perfect sandbox to understand the Ruliad because it's so incredibly simple.
Just a grid of little squares.
Right.
Black or white.
On or off, alive or dead. And the rules are trivial, like, if you have 2 neighbors, stay alive. If you have too many, you die. A child could learn them in 10 seconds.
But when you run it,
When you run those rules on a big grid, something strange happens. You don't just get static noise or a blank screen. You get patterns. Complex, evolving patterns.
Wolfram calls this meta-engineering.
He does. It's really a history of innovation in a purely digital universe. Back in the 70s, people started playing with this grid. They found blocks that sat still. They found blinkers that flipped back and forth. But then they found gliders.
Patterns that actually move.
Little creatures moving across the grid. And the sources mentioned this specific discovery in 1970, the glider gun. Why was that such a big deal?
That was the pivotal moment. Before the glider gun, people thought the game of life would just, die out or stop moving eventually.
But a glider gun is a pattern that stays in place but shoots out a stream of gliders forever. It's a machine that creates other machines.
So you get infinite growth from finite rules.
Exactly. That proved you could do actual engineering in this simple grid. You could build logic gates. You could, in theory, build a computer inside the game of life.
So you have this simple grid, but with enough gliders and guns, you can build something infinitely complex.
Yes. And what I love about this section of the reading is the shift in how they found these things. In the beginning, it was construction.
Yeah.
Humans sitting with graph paper, trying to be clever, designing shapes.
Like architects, I'm going to build a spaceship.
Right. But eventually the complexity became too much. You can't predict how 1,000 cells will interact in your head, so they switched to search.
They use computers to check billions of random setups.
They stopped trying to build and started trying to find.
They were mining the Ruliad.
That's a great way to put it. They were hunting for those pockets of reducibility we talked about, and they found things no human would ever design.
And the names. We have to mention the names.
Yeah.
The Game of Life community has a great sense of humor.
We are quite whimsical, yeah.
The sources list the Snark, the Bandersnatch, and my personal favorite, Sir Robin.
Sir Robin is a knight ship. It's a spaceship that moves in the pattern of a knight in chess. It jumps.
That is just cool. But bringing it back to the Ruliad, why does this matter to us? Why are we talking about 8-bit spaceships?
Because it proves the point about observers. The game of life at the pixel level is computationally irreducible. It's chaos. If you just looked at the raw data of the grid, it would look like TV static.
Okay.
But engineers found stable structures, gliders, guns. They found predictable islands in the chaos.
Yeah.
Wolfram is saying that is exactly what our brains do with the physical universe.
So protons, electrons, planets. These are just the gliders of our universe, the stable patterns.
That's the idea. They are the stable patterns we've identified and named. We exist in the islands of reducibility that our senses can handle. We basically engineer our reality out of the chaos, just like those game of life enthusiasts.
We ignore the noise and focus on the gliders.
We do.
That creates a direct link to artificial intelligence. Because if we're just processing rules, and AI is processing rules, how does that relate? Wolfram asks a really provocative question. What if we had bigger brains?
It's a fascinating thought experiment. I mean, think about what a concept actually is. To us, a concept is a word. Cat, run, blue, democracy.
Right. We have what, maybe 30,000 common words?
Give or take. And each of those words corresponds to a stable cluster in our mental map of the world. It's a pocket of reducibility we've identified. A human brain has about 100 billion neurons to do this work. But Wolfram asks, what happens if you have 100 trillion neurons?
So not just smarter, but vastly more complex.
Exactly. A bigger brain could hold more concepts. It could find pockets of reducibility that are currently invisible to us.
The text mentions interconcept space. What's that?
Yes. Imagine the space between the concept of cat and the concept of dog. To us, that's empty. It's just nothing. A thing is either a cat or a dog, more or less.
Right.
But a bigger brain might see 1,000 distinct, stable concepts in that gap. Things we don't have words for, and never will, because our hardware can't support them.
There's this visual the source describes with generative AI. You know how sometimes AI makes images that look almost real but have weird alien geometries, like a hand with 7 fingers?
Or a building that twists in a way that just hurts your eyes.
Yeah. So we look at that and say, oh, the AI messed up, it hallucinated.
But Wolfram suggests that maybe a bigger brain, or just a different kind of intelligence, would see those alien geometries as native concepts. It's not a mistake.
So it's just exploring a part of the Ruliad we can't reach.
It might understand those shapes just as intuitively as we understand a circle or a square. Neural networks are bounded, like us, but they're bounded differently. They find different shortcuts. They're mining a different part of the Ruliad.
Which brings us to the wildest part of this whole thing. We've talked about human minds, AI minds. What about alien minds? This is where the physics project touches on the Fermi paradox.
This is where the concept of Rulial space becomes vital.
Okay, define Rulial space for me. We know physical space meters, light years.
Rulial space is a map of rules. Distance in Rulial space is defined by translation. So, how much computational work does it take to translate my view of the universe into your view?
So if we think alike, we're neighbors in Rulial space.
Correct, you and I. We are practically standing on top of each other. All humans are clustered together, same biology, same senses. Animals are a bit further out. But an alien mind.
So the alien problem, why haven't we met them?
Wolfram's suggestion is maybe they aren't far away in light years. They might be right here, in this room.
But their minds exist in a distant part of the Ruliad.
Meaning they're perceiving the universe through completely different rules.
Wow.
Exactly. The text uses the analogy of weather mind. Imagine the atmosphere. To us, it's just wind, pressure, chaos. It's background noise.
But it's incredibly complex.
Incredibly. What if there's a coherent intelligence existing within those fluid dynamics? To a weather mind, the chaotic motion of air molecules might make perfect sense. That might be their version of order.
And to them, we would look like static, like frozen noise.
Our rigid, object-based world of chairs and tables would be incomprehensible. We wouldn't even recognize each other as alive because our pockets of reducibility don't overlap. We're too far apart in Rulial space.
That is both terrifying and beautiful. It means the universe is full of life, but we're just ghosting each other.
We are.
Can we bridge that gap? Can we talk to them?
Communication is possible, but only if we can build a bridge across Rulial space. We need shared tokens, concepts that are robust enough to survive the translation.
And this is where Wolfram brings it back to his life's work. He talks about computational language, specifically the Wolfram language, as being that bridge.
Right. He views it not just as code for computers, but as a way to formalize concepts. If we can map our messy human ideas into precise computational terms, we can potentially translate them for an AI, or maybe eventually something much more alien.
It's a Rosetta Stone for the Ruliad.
That's a perfect way to put it.
So let's try to synthesize all of this. We've gone from atoms of space to glider guns to weather mines. What is the big takeaway here?
It connects like this. The universe is an infinite computational object, the Ruliad. It contains every possibility, every rule, but we are limited, we are finite, so we carve out a slice of reality that we can handle.
Our physics, our engineering, our thoughts, they aren't the absolute truth. They're just the pockets of reducibility we've managed to find.
Exactly. And the so what here is profound.
Right.
We used to think science was about discovering the universe out there, as if it were a separate thing waiting to be found.
Right.
The Ruliad suggests that science is actually about mapping our location. It's about understanding our specific limitations and how they filter the infinite into the reality we experience.
It puts the observer center stage in a way that even quantum mechanics didn't quite manage. It implies that physics is ultimately a reflection of the mind that perceives it.
It does. It forces us to ask how much of reality is out there and how much is just the structure of our own perception.
Here is where it gets really interesting for me, and this is a thought the text leaves us with. If our perception of reality is determined by our boundaries, our computational limits, what happens if we change those boundaries?
That is the final provocation, isn't it?
Right. If we merge with AI, if we create those bigger brains Wolfram talks about, do we literally move to a new location in the Ruliad?
And if we do move, do the laws of physics themselves change for us? If we could process information faster or see those inner concept spaces, would gravity look different? Would time flow differently?
It suggests that reality isn't a fixed stage. It's a user interface. And we might be on the verge of a major software update.
An upgrade that could fundamentally change the game. I mean, imagine stepping into a reality where you perceive 4D structures as naturally as 3D ones. That's what moving in the Ruliad could mean.
That is a lot to mull over.
Yeah.
I'm going to be looking at the wind very differently on the way home today.
Just don't try to start a conversation with it just yet. We might need a few more updates for that.
No promises. I want to thank you for helping us wade through the machine code of existence today.
It was a pleasure to explore the Ruliad with you.
And thank you to everyone listening. Keep exploring those pockets of reducibility, and we will catch you on the next deep dive.